The sun went out 8 minutes ago. You just do not know it yet. Outside your window, the sky is still blue. Birds are still flying. Everything looks completely normal. That is because the last light the sun ever made is still on its way to you. This is what happens next. Light is fast, but it is not instant. It takes 8 minutes and 20 seconds to cross the 93 million miles between the sun and your eyes. So for those 8 minutes, nothing changes. You feel warmth on your skin from a star that no longer exists. But here is the part almost everyone gets wrong. Gravity is not instant either. Einstein showed that gravity travels at exactly the same speed as light. So Earth does not fly off the moment the sun vanishes. For 8 minutes and 20 seconds, our planet keeps orbiting a ghost. It curves around something that is not there anymore. It is worth asking how anyone figured this out. For most of history, light was assumed to be instant. You light a candle, the room is lit. There is no delay to measure. Then, in 1676, a Danish astronomer named Ole Romer was watching the moons of Jupiter. He noticed something odd. When Earth was moving away from Jupiter, the moons seemed to run late. When Earth moved closer, they ran early. The moons were not changing. The distance the light had to travel was. He had accidentally measured the speed of light, more than 200 years before anyone could measure it in a laboratory. That is the same delay standing between you and the sun right now. 8 minutes of the past, arriving as the present. Then all at once, both arrive. The sky does not fade, it switches off. In the same instant, Earth stops turning through its orbit and simply goes straight. We are moving at about 67,000 miles per hour. That speed does not disappear, it just stops curving. Earth becomes a bullet fired into the dark, and it will never come back. The moon still follows us. Its orbit was never about the sun, but every other planet is gone, each one flung off on its own straight line, in its own direction forever. The cold does not arrive the way you might expect. The first night is survivable. Earth holds its heat like a stone that sat in the sun all day. But that heat is only leaking outward now, and nothing is replacing it. Within a week, the surface drops below the freezing point of seawater. The oceans begin to skin over. A thin lid of ice spreads from the poles until it meets in the middle. Above the water, something quieter is already ending. Photosynthesis has stopped. Every plant on Earth is running on stored sugar, and the tank is not big. The phytoplankton go first. They make roughly half the oxygen you have ever breathed, and they need light to do it. Not that oxygen is the problem. The atmosphere holds enough to last thousands of years. The problem is that everything that eats something that once ate sunlight. After 1 year, the average surface temperature is around -100 degrees Fahrenheit, -73 Celsius. Colder than any winter ever recorded on this planet. The ice on the oceans is now hundreds of feet thick and still growing downward. And here is the strange mercy in all of this. That ice is an insulator. It traps what heat is left underneath it. So under a frozen lid, in total darkness, the ocean is still liquid water. Meanwhile, the air itself is starting to fail. Carbon dioxide freezes out and falls as dry snow. Given enough time, even the nitrogen that makes up most of our atmosphere will settle onto the ground as frost. Now the interesting question: does everything die? No, and the reason is that some life on Earth never needed the sun in the first place. Miles down, along volcanic ridges on the ocean floor, there are hydrothermal vents. Superheated water pours out of the crust, carrying dissolved chemicals, and entire ecosystems live on it. Tube worms, crabs, bacteria that build their bodies out of hydrogen sulfide instead of sunlight. They have never seen light. They do not care that the sun is gone. Their energy comes from Earth itself, from radioactive decay deep in the planet, Heat that has been running since the world formed. That heat does not switch off. It fades over billions of years. So the last life on Earth would not be on Earth. It would be inside it. So could we survive it? A few of us maybe, and not the way you would guess. Cities on the surface fail almost immediately, not from cold at first, but from the grid. Power plants need cooling water, pipes freeze, roads become impassable. But the places with the best odds already exist. Iceland runs a large share of its electricity, and nearly all of its heating on geothermal energy pulled straight out of the ground. That heat is not solar. It does not care what the sky is doing. A nuclear submarine can generate power and make its own oxygen and fresh water for decades without surfacing. Deep mines stay warm year-round because the planet warms them from below. So the survivors would not be the strongest or the richest. They would be whoever happened to be standing on top of Earth's own heat. A few thousand people, underground, growing food under electric light powered by rock. 1,000 years pass. Only now does the deepest ocean finally freeze solid, all the way down. The planet is a sealed ball of ice with a warm stone core. By now, Earth is unimaginably far away. Traveling in a straight line at 67,000 miles per hour for 1,000 years puts us far outside the space where the solar system used to be. We are not orbiting anything. We are a rogue planet, and there are likely billions of them drifting between the stars right now. Some of them may have started exactly like this. Eventually, the temperature stops falling. It settles near -400 degrees Fahrenheit, about 30 degrees above absolute zero. That is the temperature of empty space, and Earth simply becomes part of it. The continents are still there. The mountains are still there. The ocean basins are still there, filled with ice instead of water. Everything you have ever known is still physically present. It is just dark and still, and unimaginably cold. None of this is going to happen. Stars do not vanish. Our sun will burn for another 5 billion years, but it is worth sitting with the scale of what it does. Every meal you have ever eaten was sunlight first. Every breath you take came from something that could turn light into air. The reason this planet is warm and blue and loud with life is one star, doing the same thing quietly every second for 4.5 billion years. And the light hitting your face right now left it 8 minutes ago. It is still on its way. It always was.